In this video, I'm going to go over the ACT math topic called the Law of Cosines. So when would you use the Law of Sines or the Law of Cosines? Well, this is when you don't have a right triangle. If there's no right angle in there, you're going to be forced to use either the Law of Sines or the Law of Cosines. So the cases where you would use the Law of Sines is if you have two angles and a non-included side. Okay, so you always need a pair, either a side and its angle. You need a pair in order to use the Law of Sines. So you have x over the sine of 30 equal 55 over the sine of 40. Now the other case would be if you have two sides and a non-included angle. So again, we have an angle and side pair. So you can set up 55 over the sine of 40 is equal to 35 over the sine of x. So for both of these, we do cross multiplication and solve for the x. If you're solving for the angle, at the end you have to do sine inverse to get the angle. Okay, so these were the cases to use the Law of Sines. And you want to use the Law of Cosines when you have two sides and an included angle. So the angle is in between the two sides. And you want to solve for x here. So you would have x squared is equal to 35 squared plus 55 squared minus 2 times 35 times 55 times the cosine of 30 degrees. Okay, so you simply put that in your calculator, get an answer, and then take the square root. So if you do that, you get 915.802. That's equal to x squared. And just to get the x value, you need to take the square root of the 915.802, and that'll give you 30.26. Alright, so our second case is when you have three sides. They give you three sides and no angles. To solve for the angle, so here we need to use the side that's opposite the angle. That's going to be on the left side. So 50 squared equals 55 squared plus 35 squared minus 2 times 55 times 35 times the cosine of x. So here you need to subtract 55 squared from both sides and subtract 35 squared from both sides. So I'll give you negative 1750 equals a negative 3850 cosine of x. Divide both sides by 3850, negative 3850, and end up with 1750 over 3850 equal to cosine of x. And remember, to find the angle, you gotta do cosine inverse of 1750 over 3850. That gives you about 63 degrees. Okay, so the basic formula is c squared equal to a squared plus b squared minus 2 times a times b times the cosine of angle C. So these two are going to match. Those are going to be the corresponding angle and the corresponding side that you know or are solving for. A and B are the other sides of the triangle, and you're subtracting 2 times the other sides multiplied together times the cosine of C. Alright, so remember, use the Law of Sines or Law of Cosines when you have no right angles in the triangle. And depending what they give you, you're going to use the Law of Sines or the Law of Cosines. If you have a pair, a side and an angle, most likely you're going to use the law of sines. Alright, so this would be a typical ACT math problem that you would see. In the picture below, the angle at boat B is 82 degrees, and the distance C between the boats is 195 miles. The distance A between the tower and the boat B is 97 miles. What is the distance B between boat A and the lighthouse? So they give us angle B is 82 degrees. Distance C is 195 miles. And distance A is 97 miles. And we want to find out side B, the distance between boat A and the lighthouse. Okay, so what we have here, we have two sides with the included angle. All right, so when we have that, we have no pair of side and angle that we know. So it's going to be a law of cosines. Okay, so it's going to be b squared equal to a squared plus b squared minus 2 times a times b times the cosine of b. So that's going to be b squared equal to 97 squared plus 195 squared minus 2 times 97 times 195 times the cosine of 82. Alright, so we put that in your calculator. That's going to give you 42,169.08. And then you need to take the square root of that. That's going to give you 205.4. So that distance B here is going to be 205.4 miles. Alright, and here's our second ACT math problem. So this problem reads, the triangle shown below has sides 25, 26, and 27 inches. Which of the following expressions gives the measure of the largest angle of the triangle? And our note here says, for every triangle with sides of length A, B, and C that are opposite angle A, angle B, angle C, respectively, C squared is equal to A squared plus B squared minus 2AB cosine C. Now, most of the problems I've seen on the practice ACT test and previous ACT tests, most of the time they give you the law of cosine. So you don't need to memorize it, but you should be familiar with it. Alright, so on this one they give us 3 different sides and no angles. So we need to use the law of cosines. And the largest angle is always opposite the largest side. So the largest side is 27. So it's going to be this angle that we're looking for, we're going to be using. All right, so the opposite side of that angle is 27, so it's going to be 27 squared equal to the other side's squared, so 26 squared plus 25 squared minus 2 times 26 times 25 times the cosine of that angle. We just use C, it's fine. Now I need to get the cosine by itself. So if I subtract 26 squared and 25 squared from both sides, I have 27 squared minus 25 squared minus 26 squared. And then negative 2 times 26 times 25 times the cosine of C. Then I need to divide by negative 2 times 26 times 25 on both sides. Alright, once I have that, I need to take the cosine inverse of that. So it's going to be cosine inverse of 27 squared minus 25 squared minus 26 squared divided by negative 2 times 26 times 25. So if we look at our answer choices, looks like answer choice B matches up to that. They just pulled this negative that was down here out front, so that's fine. Alright, so our third example ACT problem. So this one reads, a platform makes an angle of 30 degrees with the horizontal. Line segment AB as shown below A cable that keeps an antenna stable, line AC, extends from the base of the platform, point A to point C, on the antenna. Point C is 40 feet directly above where the antenna is attached to the platform at point D. Given that the length of AD is 75 feet, what is the expression that represents the length in feet of the cable? Alright, so our goal is to figure out the length of the support cable. Okay, so far now we have 75 feet for AD and for CD 40 feet. Okay, so we don't have enough information yet to use the law of cosines to find this. But if you look here, we have a triangle basically here. We know 90 degrees, we know 30 degrees. So our missing angle would be 180 minus 90 minus 30, which will give us 60 degrees here. And this is a straight line here. So a straight line is 180 degrees, so it's going to be 180 minus 60. They give us angle D here for 120 degrees. Okay, so now we have two sides, the 40 and the 75, and an included angle of 120 degrees. So we're going to use those three pieces of information to find the length of AC. So we can just call that side A squared is equal to 40 squared plus 75 squared minus 2 times 40 times 75. That's the cosine of 120. And then get the A, we basically take the square root of that value. So the square root of 40 squared plus 75 squared minus 2 times 40 times 75 times the cosine of 120. And normally on the test, they'll give you, the 5 answer choices, and those would be in this format. So they don't want you to actually come up with the actual answer, a value in feet, but the actual expression. So this would be your setup, and then your answer choices would match what we see here. So if this lesson on the law of cosines helped you out, you should check out our ACT math playlist. We have over 70 videos and growing. So if you want to really prepare for the ACT exam, you should check this out. Just go to J Digital Tutoring and go to our playlist, and you'll find it there. And before you leave, remember to like this video and subscribe to our channel. Thanks.